welcome everybody. Before we jump in, just a real quick intro for anyone that's new to Salto, because we're not just a webinar company, we actually have a product. Salto is a Salesforce DevOps platform, making deployment smoother and more collaborative. So with Salto, you can do things like track and document changes across your org, automate deployments with granular control, and understand the impact of changes to avoid issues, and a lot more. We do offer a free 30-day trial. I'll post the link in the comments in a minute. And without further ado, let's hear it from today's speaker, Lars. Lars,
Hey,
the stage is yours.
awesome. Thanks, Baptiste. So my name is Lars Malmqvist. I'm a partner in Implement Consulting Group, which is a large management consultancy in the Nordics. I run a practice that is focused on basically Salesforce management consulting, and I am a Salesforce CTA and am the author of a book called Salesforce Anti-Patterns, which is kind of where we're going to be focusing today. We're going to be focusing on DevOps anti-patterns. And I should note that I've worked with Salto in the past. And, we've actually done a course for Salto on DevOps anti-patterns. So there's a lot of good content there. If you get inspired during the course, I'd encourage you all to go and have a look at that. Now, let's get started. So what is an anti-pattern? The way that I like to think about it is, we know what a pattern is. A pattern is it's a good architectural blueprint that we can follow to achieve a certain goal. An anti-pattern is something that looks like a pattern. It looks like a good idea at the time that you make the decision to follow it, but it reliably leads to bad outcomes. And that's how it's different from what you would say are, typical just bad practice, right? It's bad practice to put SQL query inside a loop. It's going to lead to reliable failures with governor limits. An anti-pattern is not that. An anti-pattern is something that it looks like you're making the right choice at the time you make it, if you don't think too hard about it, but it always or nearly always leads to bad outcomes. Now I'm going to illustrate that, but first, let me tell you a story. So we have a company, let's call it Growth Co. They sell specialized manufacturing equipment, B2B company. They've grown really massively over the last few years, but they have kind of a very traditional approach to IT. Most things are run from Excel or from their ERP. They haven't really had anything like a CRM in the past. That's all been basically managed in Excel. Now they've got a new VP of digital has come in, and he's gone all in on Salesforce for the sort of the front office. There's a new project to bring in Sales Cloud, Service Cloud, Marketing Cloud account engagement for the B2B marketing, order management, integration with logistics and ERP, and I'll move all of that across. Now we're going to follow Jacob. Jacob is the program manager on this implementation, and he sort of planned it as sort of a sequence over a relatively slow timeline. He's saying, we're going to go with a year and a half for the rollout. We're going to roll out one module at a time. We're going to take it nice and slow, and that's kind of what he's pitched. However, he goes to his first steerco, and is told basically by the people there, who are the senior directors of the company, that that's just not going to fly. His plan's not going to fly. They need it much faster. They need it in less than half that time. And also, they can't really deal with everything just trickling in. They think it's going to be too much disruption if they've got, 4 or 5 separate go lives over a short period of time. And also, they've kind of sold this to some big investors as a major step up in their digital strategy. So they need to be able to deliver it and say, now this thing is done. So effectively, Jacob's told that it has to be one big release, and it has to be a lot sooner than he thought. He's a little worried, but he goes back and he manages to get the right resources in place, and for a while everything looks green. And he starts facing some conflicts. A lot of the teams internally are not really that well aligned, and in particular, there is a conflict between the team managing the integrations, especially to the ERP and the logistics systems. They come from an external vendor who's got competencies in both Salesforce and the external systems. And then the internal order management team that are trying to optimize and automate a lot of their the internal like a lot of the order management process, and they can't agree about the right approach to architect anything really. Jacob's not a technical guy; he doesn't understand a lot of the detail, but effectively they have completely different architectural approaches, and they can't agree. Then somebody suggests effectively that okay, we don't have to agree. We can split the project out into different packages. The integration team works in one package, the order team works in another package. There is a little bit of overlap, but as long as they manage to talk to each other on a regular basis, it shouldn't be too bad. Jacob accepts that because it allows him to then move on with the project. So that's seemingly resolved. Then a few months later, there's another issue that comes up. So effectively, there is a special project as part of the bigger project. There's a smaller special project, which is kind of a pet project from the VP of Digital, where a senior developer has been tasked with generating an end-to-end automation for a particular order type. So the VP of Digital wants a demonstrator that shows that with the use of some clever AI technology and some clever automation, they can actually take an order type and completely eliminate human input to it. And the developer has effectively been working on that separately from everybody else, and he's now trying to merge in his project into the main code base and metadata store, and it's failing. And it's been failing for a while, and it's taking out a lot of effort and resources across a number of strands in the project, because it's not clear where the various responsibilities lie and why the dependencies are failing in the way that they're doing. So they take the decision that they're not going to deal with it right now. They know they're going to have to deal with some dependency issues towards the end of the project, and for now they're just gonna let the developer continue in a separate environment without all of the complexity in it, and then they're gonna find a way of doing it closer to the go live date, where people also hopefully have sorted out all of the existing kinks, so it'll be easier to merge everything together. That's the theory, at least. So things are getting tense. So we're now a month away from go live, and one of the members of the operations team flags that there is very low test coverage in the org. It's basically below 40%, and as everybody knows, it has to be at least 75% to deploy to production. And it's nowhere close. So that's a problem, and Jacob is worried. However, he then shows up for a meeting the following week, and somehow magically the test coverage is now well above 75. It's actually closer to 80. He can't quite figure out how they managed to do that many tests in what's effectively less than a week, but he's not gonna look a gift horse in the mouth. So now they are going to the go live. So leading up to the go live, there are lots of warning signs. There are lots of little things that are breaking, nothing big, but but it's a little bit worrying. They press ahead nonetheless because they really have to. The senior management are not gonna tolerate a delay on this one. Um, they have decided to go live over a weekend, and you know, already Friday afternoon there are major issues, and Saturday, just before noon, Jacob has a sit down with the various members of the team, and they are they can't work out what's wrong. So basically, they are inches away from having to pull the plug and roll back, which would be very embarrassing. Again, this has been promised to investors. So there is a DevOps architect that is probably the closest person to knowing, the whole system. He's been maintaining the pipeline. He's been doing all of the build integration. He's looked at a lot of the metadata. He obviously hasn't been coding it, but he has a good overview of the code base and the pipeline. His name is Chris, and he basically says, "Look, I will step up. I think if you just give me carte blanche to make changes, I can get this fixed." And he effectively works through the next few days, 24/7, with a few other relatively junior members. And you know, there's a delay. They have to flag a delay, and the release doesn't happen on Monday as it meant to. But by Wednesday, there is something. You can go into the system. You can create opportunities and sales orders and things like that. However, a lot of the clever things are not there, right? The end-to-end integration that the VP of Digital was so excited about, that one is gone. A lot of the integration features, they aren't really working. They've basically had to cut out a lot of overlapping stuff between packages in order to get the whole thing to work. So they've had to strip down the project in a number of areas. Also, it's buggy. It's really, really buggy. There's obvious things that should have been tested that just seems to fail. And yeah, obviously the user response is lukewarm, but there's something there. Over the next month, they keep firefighting, and they keep effectively having to work crazy hours just to keep the system running. Chris, the guy that initially got the thing up and running, in less than a month decides to quit to find a job with a better work-life balance. At the Steerco, a month after the go live, the decision is taken to make a partial rollback of processes to the old ways of working, while the system is being, upgraded and reevaluated. So that is to some extent just recognizing reality, because a lot of the sales guys have just gone back to using their old Excel sheets and without, and not bothering with the Salesforce system at all. And that is my story. Now, that is a lot of information to take in one go. So let's take it a little bit slower. And then let's see what actually was happening here and how we could have avoided this predicament. So the first thing that happens is that we have a relatively low risk incremental go live plan, and that is replaced with a big bang release with lots of interdependent products. Now, big bang release is an anti-pattern where effectively you try to get everything out at once. And, it's somewhat contentious calling it an anti-pattern because, in some situations, in some organizations, you don't really have a choice. You have to do it that way because of other constraints. But in general, the reason why big releases and complex releases are risky is because we bundle too many changes into a single event, right? And that creates a huge web of dependencies, which means there's often overlapping changes in the same area. They're not necessarily managed well. Also, complexity doesn't scale linearly. It scales, at a pace that's faster than linear. So if you've got 3 components, you've got like a limited number of interactions, but scale it to 8 different components, it starts becoming unmanageable just because there are so many potential paths between um, the different parts of the system. So you can manage that to some extent by modularizing and having other architecture patterns, but it becomes hard. And it certainly requires a lot more engineering effort. So smaller, limited releases based on good, well-tested DevOps frameworks are a lot safer than big bang releases. So that's the first thing that happens there. We take a relatively low risk deployment approach and we replace it with a high risk um, deployment approach. So that's kind of the first thing that happens in this story. Then we have a very common coordination issue when you've got these 2 teams that are at loggerheads about how to resolve an architectural issue or what standards to follow when developing something. That's an anti-pattern that's called using packages to create silos, right? So a lot of the time, people like silos because it means they don't have to coordinate with other people. And that is very understandable because coordination is hard, right? Especially when we have, in this case, they're coming from different companies. They don't have the same standards. They've got different libraries they want to use. And, nobody really wants to change their way of working, especially not mid project. So, finding a way of splitting off into independent groups can seem like a really good idea. And one of the things you can do that in Salesforce is by dividing up into packages. This is actually a more general anti-pattern. There are other ways in which you can get into this kind of miscoordination issue, but in Salesforce, it often happens when you effectively let people split into different packages without really managing the dependencies between those packages in any clear way, right? So if you don't have a good package architecture, you split into different packages. It looks like you're doing independent development, but actually, when you then try to bring them together, all sorts of havoc ensues. So, and obviously that means when we get to the go live, the integrations aren't working, right? Because they're overlapping with stuff in the order management, and they effectively have to pull out a bunch of functionality in order to get the system working. Like it's it's very predictable if you see it coming, but if you just want to let people get on with their work, you may not check, right? You may never get to that. So this is kind of one of the really good reasons to have continuous integration running all the time, so that you make sure that any conflicting dependencies are worked out early. But again, that requires governance, that requires coordination, and often that is something that companies are a little loath to invest in. Now we have this super important special project developer who tries to merge in his code after having worked on something for a long time, and it breaks a lot of things. That's perhaps one of the most common anti-patterns. You see it all the time, and it's it can be hard to avoid because like sometimes it's just people going on holiday at the wrong time, and then they leave something that hasn't really been finished, and that then ends up messing with everything else when they do get back. But in this case, it's a conscious decision, right? We're letting somebody build in a silo, and this is another variant on this coordination issue, right? So if we've got a special project, like good management theory actually tells you should put it in the skunkworks, it should run by itself. But when it's part of a project or a program, like in this case, that can it creates effectively a time bomb, right? It's it's going to say tick 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 tick, and then you're going to try to merge it in, and lots of things are going to break because you have not got the coordination between the two parts. So first, he's going to have to figure out all of the things that have changed since he started doing his development. He's going to have to merge that in, and he's going to have to merge in with the new code base, and ultimately that work can be very difficult and very frustrating, especially when on a large distributed project where lots of different parties may be modifying the same parts of the solution in different ways. So that is a problem. And again, ideally you should never leave a feature branch open for more than a day, right? You should check in continuously. You should not have lots of long-running feature branches, long-running skunkworks projects that are running, and you should be able to catch integration errors early and often by having the good build automation tools in place. And again, that goes then back to, you also need to define scopes of work in a way that is manageable, right? And here we've got this end-to-end special project that automates an entire horizontal slice of the application, and that's that's really difficult to manage when you've got other people working at the same time. So how you break projects down and how you break stories down into reasonable chunks is also really important in order to avoid these kinds of coordination issues. So then we have another one. How is it that the unit tests magically start working in the process of a week? Well, that's because the people behind the scenes have written dummy unit tests, right? So the Salesforce test coverage analyzer doesn't care whether your tests are meaningful, right? You can just write code that hits, like test code that hits code lines without doing anything at all with them, right? You don't have to write a good test. You don't have to write a reasonable test. You can even do something like creating a class that's a dummy class that has 1,000,000 lines in it, and then you can write a test that tests that one solution, and your test coverage will go to the sky because those 1,000,000 lines are now counted for test coverage. And people, unfortunately, still do that relatively frequently, and you're basically just gaming the system, right? It's not a it's not a good idea, right? The coverage requirement is there for a reason, and in our example here, we see that lots of obvious things are buggy, and if lots of obvious things are buggy, you probably don't have good enough test coverage, whether it's on your functional tests or on your unit tests. So it is you do it once, probably not gonna harm, but it's death by 1,000 cuts. You just get into this pattern where actually you think that you've got test coverage, but it's actually not real. So it's sort of a false sense of security that can end up. And it, obviously for Jacob here, who's not a technical guy, he's a program manager. He does get a false sense of security from being told that the test coverage is up, right? He might have responded differently if they'd been honest about how well the solution actually was tested. So always build good unit tests and meet the minimum thresholds. It is not something that you should compromise on, even when you can't meet your deadline, right? Then it's not optional, right? If you've written the code but you haven't written the tests, you're not done, right? So that means that that you are actually behind. It's not an optional step that you can just skip by dummying it out. And some people still seem to think that that's the case. Now we have to go live. Everything is failing for some of the reasons and more that we've discussed so far. And we have somebody who steps in single-handedly to save it, or almost single-handedly. He has a little help. This is, I think, everybody's favorite anti-pattern, because most people in IT at some point in their career ends up being the hero on a project or two, right? It's, it feels so natural that when things are just breaking, um, somebody has to step up and try to fix it. And you know what? That's fine. If it happens once, that's really good. Give people a bonus. It's lovely. But if that then is just something that continues, that's just the way that you keep normal operations running, or you know, everything is firefighting all the time, and we have to um, keep firefighting just to keep the system running. Then you have a problem, because the hero will start to feel the pressure. And like, the key problem with heroes is that they don't scale. You can't just put people in a people cloner and then get as many of them as you need. Which means that they are single points of failure. And because they are always busy, they're going to do things the easy ways. They're going to accumulate more technical debt. They're not going to have time to explain how things were implemented or document anything, which means that when they eventually do break down, you're in a really bad situation. So, as also happens in our example. So what does all that lead to? It leads to, a predictable disaster, as in this case. So an unmaintainable mess that they have to effectively roll at least halfway back from. Okay, so we've seen some anti-patterns now. We've seen how they can lead to issues in a particular example. But I'd like to just zoom out and have a look at, so where do they come from, right? I've talked about some of the things as when we went through. So in the example that I've given here, like imperfect coordination was a really big issue, right? There's lots of coordination issues that can lead to anti-patterns, because it is easier to find a way of doing things separately, or doing things in a suboptimal way. And I think that's especially true when we talk about DevOps. DevOps anti-patterns are very prone to come from bad coordination, because a lot of DevOps anti-patterns, they effectively deal with dependencies. So you've got dependencies between different parts of the system, different teams, different members of the team, and that coordination is difficult. And then you replace a simpler problem because the coordination problem is harder, and then you get an anti-pattern. Also very important for DevOps is inadequate practices, right? DevOps is all about having a good setup of practices, and a disciplined way of doing things. And when you lack that, you can end up making bad decisions, and also be forced into anti-patterns like a big bang, where the better solution would have been to do it more incrementally. Misalignment between different parts of the organization, different goals, can also be an important contributor. That's less obvious in the example we have, but for other anti-patterns, that can be quite important. Governance, of course, good technical governance is often overlooked, right? Because it seems like, why do you need a design authority? They're just going to sit there and they're going to make stupid decisions that block us from doing what we want. And, there's also all of these standards, and they slow us down. But they are there for a reason, right? They're there to ensure that we can actually solve some of these coordination issues that I was talking about before. And without governance, there's really no one to enforce that happens. So strong technical governance, another absolutely key factor in preventing anti-patterns from creeping in. The last two are kind of obvious. You're under pressure. You tend to do things in a suboptimal way, or I guess you are more prone to accepting that something is a good idea if it solves your problem when you're under pressure, right? So, I don't really like it when I'm struggling to release. I don't really want to hear about all of the problems. I want to hear somebody who's got a solution. And if that turns out to be a bad solution, well, nobody else had a real solution, right? So that can happen. And of course, over optimism. I think a lot of the time we genuinely think that it's going to work, right? We think that this time is different, and we are going to do it later, and we are going to fix it later, and it is going to be easier to do at a later point in time. We saw that with a few of the patterns here as well. All right, so what to do? Instead? Now, for DevOps anti-patterns in particular, I actually think that establishing a mature DevOps culture will tend to eliminate most of these anti-patterns from ever occurring, right? This is one of the areas. It's not true necessarily for all areas of project implementation, but when we are sort of focusing in on the DevOps area, I actually think that DevOps culture is almost geared towards eliminating these kinds of anti-patterns. So, the question of how you get there, well, I mean, you need to get the foundations right. So that will be just getting everything in source control, making sure that you check in on a regular basis, that you've got a pipeline for deploying. Then, moving faster, doing more incremental deliveries, having more automated testing, all these things. And on Salesforce, like architecting right for DevOps, because Salesforce is not a platform that necessarily makes DevOps easy, right? That's why there are so many tools to help us out there. And you need to architect your solution in the right way to take advantage of a good DevOps strategy. That might mean doing strategic packaging of particular modules, or moving to more of a package-based model, but it could also be in other ways, as long as you have a clear view of how your application is modularized, what lives where, how you deploy the different components, and that is that allows you to manage the dependencies in an intelligent way while you're delivering. And then the last thing is really to get this culture of continuous improvement running, right? For me, this absolutely critical to DevOps projects, that or to DevOps culture, that you continuously find ways of tweaking the process, making it a little bit better here, automating another step there, incorporating new tools and new ways of working that makes everything a little bit more efficient while you're building on top of this really stable foundation. So that's kind of easier said than done, but that is kind of the path towards it. And once you get there, I think genuinely you are much less likely to reach to fall into any of these anti-pattern traps, right? So to some extent, DevOps culture is a bit of an antidote to anti-patterns, to adopting anti-patterns. And with that, I will say thank you and move on to Q&A. Let me see.
Cool. Thanks, Lars. For anybody that's here, the Q&A are open. So now is the time. If you have a question for Lars, we'll still have a few minutes. So if you want to get a question answered about the topic specifically, or anything that relates to Salesforce DevOps, as Lars is an expert, yeah, feel free to use the Q&A module. We'll stay here for a few more minutes. Otherwise, Lars, was there anything that you feel like you couldn't include in the slides because you didn't have enough time, or anything?
Yeah, I mean, I guess like what people often ask when it comes to Salesforce and DevOps is, well, like we have these variety of tools. We have the DevOps Center. We have a lot of vendors. We have a lot of open source tools. We've got, there's a lot of material out there, but we don't really know how to get started, right? I'm standing here and, in Salesforce terms, a lot of organizations are still relatively immature when it comes to DevOps practices. And it's all well and good that that someone like you comes and says, we have to do this, that, and the other thing, but we're not quite there. So where do we get started, right? That is that's a very common question, and in general, I mean, the answer is to start with the basics, right? I just as a simple question of, do you have all your metadata in source control? Right? Do all of your both admins and developers have access to source control? Can you see it there? If not, great place to start. Do you have a way of deploying automatically to your various environment? Okay. If not, that's a great place to start. You can start very simply. You can start with just learning the command line tools around SFDX and things like that, and then you can move to more advanced tool chains later. So actually, you don't need to do this. You don't need to adopt DevOps in a big bang way, right? You can do it in quite an incremental way that takes you from whatever your starting point is to the next level. It's not necessarily something that has to be done all at once. And there are lots of good resources that will teach you the basics and how that can move you from a starting position. And again, it doesn't need like another good question there is like, is this only for large organizations, right? Sometimes it can seem like a DevOps pipeline is only for the really large Salesforce orgs, but honestly, anyone can use it, right? I will use it for my developer org when I'm just deploying something, and you probably in many cases you want to do that even if you're an awesome admin that's the only guy in your organization. Like that can be real value in integrating some of these tools in your day-to-day workflow, so that you always have the option of rolling back, so that you can do reviews, so you can track changes in a more systematic way, in a way that you can't with just the standard tools. So I think no, there is actually a lot of value in even small scale adoption. And then of course you then want to get on a level of, like, on a journey towards maturity, and what maturity looks like will be different whether you're one admin in a 50 user org, or whether it's many thousand licenses in an organization with a large IT department of its own. That will look different, and the tool support you need will look different. But
Mm.
um, it is, I think, the principles are relevant to everyone, right? Mm. Another thing I guess I didn't talk enough about is just how DevOps fits into the overall architecture, right? Because sometimes you've got this sense that DevOps lives separately from um, the other architecture and development disciplines, right? So I think that's a dangerous mistake, actually, right? And there's a reason why when you go for the CTA exams, one of the domains is around deployment and lifecycle, which is effectively DevOps. And it's because it's actually critical to delivering projects successfully that you think about the overall architecture in a way that also incorporates how it's going to be deployed, how it's going to be maintained, what is the life cycle around it. If that is misaligned, you're setting yourself up for a lot of trouble. So it's an important point to not think of DevOps as this thing that's that's by itself over in the corner. So I guess that's those are some of the things that people would often comment on, I guess.
Right. All right. Thanks for that additional info. Still no questions, so I guess we'll wrap it up. I'll just post a quick poll about today's session. If you have a second, please do make sure to fill it out. And in the meantime, thank you again, Lars, for today. And hopefully we'll see you for some other webinar in the future.
Thank you.
Awesome.
Awesome. Thank you.
Bye, Lars.